Hello, and welcome to this Oztech Science Commentary, part of a series looking at how science and technology affect our world. Science and its practical expression, technology, influences, changes, and often controls our personal lives. Yet, despite its obvious benefits, it is also dangerously affecting the environment and threatening the future. But science and technology are amoral. It is how we choose to use them that is important, and as with all things human, those uses can be good, bad, or indifferent. This video examines the catastrophic processes threatening future climate change, the accompanying mass extinction, and the justification for an extinction rebellion. Although there is often talk of future climate calamity, and there is much information if you look for it, how it will come about and evolve typically escapes the popular media. Much has already been said about climate change. Its processes typically drawn out over millennia, with their complexity making explanation and prediction difficult. Yet paleoclimatology has revealed much evidence from the past, showing we must be very careful with the changes we make to the Earth's delicate environment and its subtly interlinked processes. Climate might change slowly in human terms, but it moves with great momentum, and perhaps rather more quickly with the massive changes we are currently making. The Earth has been known to naturally correct massive climate changes in the past, but often taking millions of years to do so. What is known for certain is that past climate changes left their brutal record of extinction in the rocks, and that the environmental changes we are now making closely follow that of a devastating event in the past. The ingredients that were there then are here now. The paleosciences show we are in clear and present danger of making the Earth incapable of supporting either ourselves or the majority of those other creatures, unfortunate enough to share the planet with us. The most well-known extinction event was the asteroid strike on the Mexican Yucatan Peninsula that ended the age of the dinosaurs 65 million years ago. The devastating impact of a 12-kilometre diameter ball of rock approaching at 30 kilometres per second produced a continent-engulfing firestorm and a climate change in the form of a decades-long planetary winter. Yet this produced only a 65% extinction and pales into insignificance with an earlier mass extinction event that ironically cleared the evolutionary path for the dinosaurs. This earlier extinction, far worse even than that brought about the dinosaurs' end, was the result of carbon dioxide triggered global warming that wiped out 96% of all species and left life on Earth hanging by a thread. How do we know? The story is in the rocks, and it is one we would be suicidally foolish to ignore. What happened then is in store for us now. A tale of planetary devastation that, told in outline, lasts but a few minutes. Today, the Earth is at least 1 centigrade degree warmer than before the Industrial Revolution. For almost 300 years, energy has mostly been produced by burning fossil fuels. That burning, of course, produces carbon dioxide. Carbon dioxide is already notorious for its role in global warming, but it is also intimately linked in other ways with the well-being of life, and its increasing atmospheric concentration poses additional threats. Let's set the scene. 252 million years ago, at the end of the Permian era, Earth teemed with life on land and in the oceans much as now. Although there was insect life, there were no birds. They came much later. The birds, of course, are the only living direct descendants of the dinosaurs. But there is one vast difference between the end of the Permian and now. Today's world has already suffered considerable environmental damage and massive extinction through uncontrolled exploitation. Around 60% of all vertebrate species were lost in the last 40 years alone. Back in the Permian, and what is now present-day Siberia, the Earth's crust split open. A massive volcanic eruption known as a flood basalt flow, and lasting many, many years, released colossal amounts of sulfur dioxide and carbon dioxide gases. The sulfur dioxide initially cooled the Earth because it forms acidic aerosols. They would appear to us as a white haze in the upper atmosphere, reflecting and scattering sunlight. But the carbon dioxide greenhouse effect eventually dominated as the sulfur compounds were removed over time. Today, we are releasing carbon dioxide much faster, and there's no sulfur dioxide to reduce the effect. However, raining a mixture of sulfurous and sulfuric acid is not a price most of us would want to pay for global cooling. Land warms faster than the ocean. Water is very good at absorbing heat. Global warming brings increasingly destructive weather with ever more violent storms and heavier rainfall. Warmer air just holds more water. Becoming ever more unpredictable, bouts of severe flooding punctuate longer periods of severe drought. The melting of billions of tons of polar ice will raise sea levels and cause massive floods, displacing tens of millions. But there is also something else, a vast unknown. Such a large quantity of fresh water could disturb the deep currents transferring heat around the planet. Their interruption could decrease the flow of equatorial heat to the northern hemisphere. Like climate, the factors controlling these currents are complex, and the specific effect of global warming is by no means certain. Nevertheless, the planetary juggernaut that is climate change gathers momentum, accelerated by the loss of polar ice. A phenomenon known as positive feedback, where the change caused by an effect in turn causes the effect to increase, thus increasing the change and so on, almost guarantees runaway climate change. As the polar caps melt, together with other surface changes caused by warming, they become less able to reflect sunlight back into space, accelerating global warming as more heat is absorbed by the land. At the poles, the effect of warming is to increase the amount of warming. Business people may rejoice at the thought of ships travelling through the North Polar regions, no longer encumbered or impeded by ice. Their joy might well be short-lived. Carbon dioxide's increasing atmospheric concentration makes it a 2x killer, doing far more damage than just warming the Earth. Shellfish, corals and other life with exoskeletons start to die because some of the extra carbon dioxide in the air dissolves, acidifying the oceans, that is, their pH decreases, making shell formation increasingly difficult. Global warming's first stage mostly affects the land. As global warming exceeds 5 centigrade degrees, the oceans from which life first appeared now turn deadly, suffocating and poisoning the creatures they once nurtured. Life-giving oxygen disappears from the warming oceans because it doesn't dissolve so well at higher temperatures. And today, land runoff containing fertilisers, fostering algal blooms that compete for the remaining oxygen, are amongst a number of factors making matters even worse. In badly affected regions, bacterial life copes with the lack of oxygen by switching from oxidizing to reducing processes, which produce lethal hydrogen sulfide, commonly known as bad egg gas, and which, despite a smell that amuses some, is even more poisonous than hydrogen cyanide. Marine animals and fish die, leaving the affected regions dead zones. Positive feedback strikes again, accelerating climate runaway. Accompanied by melting permafrost, warming oceans begin releasing vast amounts of methane gas, which has a much worse greenhouse effect even than carbon dioxide. So where did the methane come from? Over millions of years, the accumulated remains of sea plants and creatures on the continental shelf decomposed, producing billions of tons of methane, which, because of hitherto low temperatures and high pressure, were locked up in a crystalline form known as clathrates. Unfortunately, the clathrates are unstable in warmer conditions and decompose, releasing the methane. Global warming dramatically increases. As methane release raises global temperatures in excess of 10 centigrade degrees, land extinctions accelerate. Back in the Permian, lush forests perished, replaced by arid deserts, and life retreated, almost never to return. Large parts of the land became uninhabitable. The region between the tropics, a dead zone. Life hung on in odd corners and in the polar regions. The recovery, when it came, took over 5 million years, somewhat longer than which most of us have at our disposal. Just think for a moment and compare our still hospitable, although increasingly damaged world with lifeless Mars, a planetary desert of often violently oxidizing dust. Do we really want to kill the planet of our inheritance? Is it not our responsibility to let our children inherit our inheritance? Or is humanity really that selfish and short-sighted? The events described here are based on paleoclimatological research about the Permian extinction, which also had a carbon dioxide kickstart. The account is grossly oversimplified, in particular omitting the effect of global warming on the vast oceanic currents like the Gulf Stream. The land masses had a very different shape then. Or the partial removal of dissolved oceanic carbon dioxide by precipitation. Yet it nevertheless shows, because the same ingredients present at the end of the Permian are here now, that global warming is an existential threat, whatever its destructive pathway, and that this past event is far too likely for comfort. No matter the vast amounts of carbon dioxide belched into the atmosphere by Permian volcanoes, we are now releasing carbon dioxide at an even greater rate. Catastrophic climate change may not follow the exact pathway described here, but it is likely to be close. We must slow and stop carbon dioxide release immediately, because whatever the exact nature of the consequences of us not doing so, they will arguably spell the end of the world we know and love. That is why young people are right, and action cannot be delayed. Inaction, or even the little unguaranteed action already planned, such as the Paris Accord or the 2050 aspirations of some governments, will still bring about climate catastrophe, accompanied by a colossal mass extinction. In a nutshell, 2050 is too late. Action must start now. Corporations and corporate-tamed politicians love distant future dates, because inaction is easily masked by words of care, concern, wrapped in vague promises, even from the very few who understand the science, and there are very few of those. Such is the nature of love for power and profit, that nothing will be done, unless there is no choice but for them to act, a point readily illustrated by motivation at the personal level. How much climate action would you take? Get rid of the car and use public transport, or even just use a smaller car? Fuel consumption is directly affected by vehicle mass. If there is insufficient public transport, would you be prepared to pay more tax to fund its construction? Would you reduce your flying, or not fly at all, perhaps agreeing to an air mile limit for all air travellers? China has shown that high-speed rail is a much more efficient, cost-effective and potentially environment-saving transport system. Travelling at around 300 kilometres per hour, and with stations located in urban centres as opposed to airports which are often remotely situated, high-speed train journeys of up to 1,500 kilometres typically take less overall time than flying. The options are there. Are we prepared to use them? Such is human nature that without mass public pressure, governments, often prone to behind-the-scenes corporate manipulation, which I guess is a euphemism for bribery, will not carry out the vast, intricate and very rapid changes essential to preserving our environment. That action depends upon a general awareness of what is happening, yet scientific awareness and understanding is very much at a premium, even in countries delivering quality education. It is therefore the responsibility of those who are aware to organise, educate and demand the changes necessary for humanity's survival. Full marks to Extinction Rebellion. I'm Terry Morris. Thank you for watching, and until the next time, question and discover.